Okay, so it's 2 p.m. and we can start. Also, before we start, just a message about the egg hunt cards, the ones that the first 50 people who came to this event got. Just if you are not planning to use it, then just please give to someone else because we still have a lot of prizes, so it would be um, not good if we are not going to use it. And so for now, for today's speaker, we have Daniel, who is a software engineer with experience in both local startups and global VC backed companies. And today he's gonna present Python containers. So the floor is yours and you may start.
Thank you. All right. Yeah, hello, everyone. Thanks for coming to the session after lunch. This would be around siesta time in my country, so you're welcome to take a nap. And today, we're going to talk about containers and best practices regarding specifically Python containers. This talk is going to have a bit of a different spin to maybe what I originally planned or what other talks regarding this topic have. The reason is that, well, if you search for container best practices in like the Docker documentation, literally the first thing that you will get is multi-staging and stuff like that. This is good, this is fine, and you should know about this, and it's tremendously useful, one of the most useful practices and in general best uses you can make of your container file. But I feel like it's been talked about enough, and you can easily find information about this. So I will have a kind of different spin to this. I will try in a sort of Socratic way where I will play devil's advocate for myself. You will see what I mean in just a minute, to advocate for these good practices and not just the practices themselves, but why we need or why we would want to apply them. Writing a good Docker file is very verbose. This is one of the problems that I think we have in this space. I hope that someday it will kind of start going away and more things will start being built into the images or preset into the images so that we won't have to do so much container file manipulation to get to where we want to get at. But at this stage, it is still very lengthy to have a clean container file. So what I will try to do is partly convince you of the reasons why you would want to do it, and also maybe give you some tips from personal experience or just comment some things that you might not have heard elsewhere, hopefully, so that you can get something out of this that's not, the first result of Google search. So I have essentially two tips or two big topics that I want to comment. It's only two things, but these are, I think, the two most fundamental things that you need to take into account when you are writing your container files. The first one is applying the principle of least privilege. This is a very a common phrase or a very common saying in cybersecurity, but it's also, I guess, a very common sense type of quote and a very common sense principle that you can and should be using in your container definitions. Now, how does this translate into specifically container files? You would do this by using the user instruction. So you have your, you would normally want to switch from a root user if you are using it to a custom one that you have created with specific and scope down permissions. Now, you might argue against this, and you would have good reasons to. This is the first character you will meet in this presentation. There are two of them. Thinking emoji will provide sort of objections to the things that we will be saying, and reasonable objections at that. So this is, the devil's advocate. And thinking emoji will tell us reasons why you might not want to do this. So this is like the little devil on top of your shoulder that tells you why you shouldn't maybe do these things. And these objections are partly reasonable. Containers are supposed to be black boxes of some sort. They are isolated. You normally don't really care about the underlying operating system because you might just send them over to be hosted or deployed in a cloud service. So you don't necessarily care about the underneath system if it leaks. And they are, on paper, you could think, well, I don't really care about what's happening inside of the container. As long as it stays there, it's not going to leak out. And even if it does, it shouldn't be that important. Well, the truth is, and this is the second character you will meet, the nerd emoji will provide kind of the, let's say, good perspective on things, or why you should actually care about these things and take the time to write all of these very annoying lines that kind of bloat your file, but you should do it anyway. So containers are isolated. That is true to some degree, but it's very easy to leak things. For example, you cannot count out on container runtime vulnerabilities. You cannot count out that something will be wrong with the kernel and you might have some sort of exploit. It happened before, it might happen again. And you should sort of preemptively protect against those kind of things. Also, if you have, if you're under a supply chain attack, and I think in general we are playing with fire in Python in many cases with this kind of thing, and I think a big one is probably bound to happen at some point. So if a supply chain attack happens and you install a malicious dependency, if that's installed with super user privileges, or you have something that has access to all of the context, especially if you use mounts and you're not careful about what kind of volumes you're mounting, you might be, well, asking for trouble. And these malicious dependencies, if they are scoped to the, let's say, if you deploy them within the scope of only your application code, well, it's still terrible, but it's not as terrible as it would be if you just give them permission to anything. Also, you might be breaking some SLAs or something. So, you know, I'll call the police and you'll lose your job. No, I won't. So back to the user command. So there are, very broadly speaking, there are two types of containers. The ones that provide you with an application ready to use, let's say Airflow. The Airflow container does have an Airflow user that's preset in the container, so that when you run that container, you're using the Airflow user. That does not happen for Python containers or for containers that do not provide directly an application in the first place. The reason is that you are kind of expected to do this yourself. So let's say when you provide this container, you don't know what it's going to be used for, and you don't know what scopes it will have in terms of what folders it will access or what you will use it for. So you are kind of expected to be to create your own users and your own groups to be able to delimit what your application is going to do in that context. That is not necessarily the case if you are using a container for a pre-bundled application that already has its own boundaries. But you are expected to do this if you deploy an application with a Python container. So the way you will do this is, like you see there, this is ripped straight out of also the best practice documents. And just to comment, you should well create the user and the group. It's considered by many people good practice if you also assign a UID. You switch to it, and you generally use that for all of the different operations that you will do that do not strictly require root. Those would be system application installs. And by system application, I mean package updates or dependencies that come from the operating system. For those, you will need root. And then what you should do is switch over to root, do the operations that you need to do, and then switch back with the user instruction to the user that you created previously. This is almost essential. And yeah, it's again a bit verbose, and it kind of sucks that we have to do this, but it's for good reason. So for extra brownie points, if only the user has permissions over the application's executable files, that's perfect. But at the very least, this is the kind of the bare minimum. Another kind of tip I have, or something that you might want to explore, is Podman. This is a sort of drop-in Docker replacement. It's gotten quite better the past few years. Before, it used to be it used to not have very good developer experience. Some things would break, some things were not as good. Things like networking were kind of slow. Now it's gone progressively better. And the trick about Podman, or the magic about it, is I don't want to take too long about this, but just so you know, Docker has daemon in the system. So when you start up your system, if you're using Linux with systemd, Docker will have a daemon that has super user privileges. And then the command line interface is it connects to the socket for the daemon, and the daemon is the one who actually runs your containers. Thus, those containers have or are running under a super user namespace. With Podman, it works a bit differently. So Podman is a process that's started under your user, so under your local user that you have in your machine. And when you spawn a container, it forks off of that process with the same permissions that your user has. So this is a good excuse to kind of exercise what kind of super user privileges you might be abusing in your applications. For example, if you're trying to create folders with root permissions, you're trying to access system files that you shouldn't be able to, this will not work initially, and you will have to fix it. One very common thing that has happened to me thousands of times, and I guess maybe to you too, is that you have you mount a volume in your file system, and then you try to delete it for whatever reason, and then you see that you don't have permission to do that, and you have to use root to delete it. That, if that happens, it's not necessarily bad, but it's a sign that you are kind of potentially abusing your super user privileges, and root is creating files under your file system that should be your property, let's say. So you can give it a try. It has, for the most part, feature parity to Docker. You might find quirks here and there, but it has gone quite better. Some people think that this has some other advantages to Docker regarding open source ability and things like that. That's not true. Docker is open source. So is Podman. They're controlled by different companies. Docker is by Docker. Podman is by Red Hat. So pick the one you like the least. But essentially, they are kind of interchangeable for the most part. The second thing that I want to comment is that the smaller your container, the better. This sounds like a very strong rule of thumb because it sounds very like maximalist. Do I always have to make things as small as possible? Well, it turns out that for the most part, yes. It sounds kind of too strong, but it often ends up being the case. And Thinking Emoji has some opinions about this. Do you really need to care about this? So differences between containers will be in the order of megabytes. So it's not like you will have a container of 1 terabyte and then one with 5 megabytes. Besides, transfer speeds are pretty high, and storage is quite cheap nowadays. So what's the big deal with this, and why should you care so much about reducing your container size? It seems like some sort of code golfing exercise applied to containerization. It turns out that that's not entirely the case. There are many good reasons why you would want to make your containers as small as you can. The first and most important probably is that the smaller your container, the safer it is, kind of by definition. You might have heard about one of the latest exploits that happened with SSH, where it had a very big vulnerability. There was another really big CVE with cups, the printer system. And if you're thinking, well, why should I have any of that in my container? That's exactly the point. You shouldn't. You don't really need it. And if you can remove those kind of entry points for potential vulnerabilities, your container will, by definition and by conception, much safer and much more secure than one that's bloated with potential vulnerability entry points. So that's the most important one. But it's not the only one. It also happens that even though differences in size between containers are relatively small, you get, on one hand, charged a lot for data transfer in many cloud services. And especially if you're doing like evil things like transfer between availability zones, or you're using egress through an ad instead of a VPC endpoint, stuff like that, the charges will rack up, and you will start to notice them, especially if you do things at scale. At the same time, it's also faster, and that also kind of translates to money at some point. If your runners are, if your CI/CD pipeline has to pull the container, and that container is bigger, may not matter a second in like one deploy a week, but if you're doing multiple deploys a day, then it might start to rack up and you might start to notice it. So it's actually more important than it would seem at first glance. And the way that you would reduce your container size is normally by the base image selection. I will speak first about the Python images because those are the ones that are more central to us. If I have time, I will digress a little bit about other options you might want to consider. But for now, let's speak about the ones that come from the official Docker Hub. So you have three. The first one is the base Debian image. So it's the one that doesn't have any suffix. This is okay, but it's probably too bloated. If you read the Docker Hub README, and if you check out the description for this image, you will say that they recommend using this. I don't want to be presumptuous enough to like contradict what the people who build this actually say. They certainly know better than me, but I think this is too much. I think you will probably not need many of the utilities that this one has. And I think you can, for the most part, use the slim version without any penalties. If you need something that you don't have in this base image, you can just install it and it's totally fine. It's much better to start with something very small and only install what you need than to start with something bloated and kind of also assume or rely upon utilities that you're not explicitly calling up. Also just the size is much bigger. Lastly, the Alpine version is the most controversial of the three. So Alpine, I think everyone knows at this point, but Alpine, the trick with Alpine is that it's a distribution that doesn't use libc, it uses muscle, which is a different, let's say, C variant to keep it simple. It has historically been troublesome with Python, but this is one of the things that I sort of want to, or I will go a bit against the grain in this. You will hear many like container experts and a lot of people who work very often with Python discourage the usage of Alpine, partly because of many of these caveats. Some do apply, some don't, but it has gone quite way better with time. So some software might not work. I think this is getting rarer and rarer. It still might happen. Worst case scenario, you can use gcompat, but at that stage, just don't use Alpine. Another reason why you might care about this is that the muscle memory allocator is slower than libc. So if you are doing a lot of operations like malloc or string length or string copy in C, this might actually hit you. It's not a massive performance difference if like for normal workloads, and besides, you shouldn't care that much about it for many regular use cases, but it is a fact. This is true, and you can benchmark it, and it comes out. It still kind of is a bit the case. It's gotten quite better, by the way. So it has improved a lot. 5 years ago or something, it was very noticeable. Now, not so much. Lastly, and this is the most important point, some wheels may not be available for Alpine. So what happens is that you might install a package that has some C inside of it, and the wheel might not be available, so you will have to compile that package when you pull it. This is actually one legitimate reason why you might not want to use this distribution. It's much better to use grab the wheel, faster pull times. You don't have to compile anything, and it's much quicker. So these are all legitimate. However, for the most part, it works okay in all other cases, and these are starting to become more and more corner cases and less applicable to many to many, let's say, regular use cases. So what you see on the bottom left, it was well known that for some time Alpine had a lot of problems with DNSs. A lot of people using Kubernetes really complain about this. It's now gotten almost fixed, or even completely fixed. I haven't found anything particularly troublesome when using it myself. This is a relatively recent change. The message you see there is 2 years ago, but there's one below where the version in which the change got applied to muscle, to Alpine, which bundled the muscle version, was kind of a year ago or so. So it's quite a recent change, but it is steadily getting better. The availability for wheels is also getting much better. So you will find now that many common packages bundle wheels for muscle. And what you see on the bottom right is a list of dependencies of one of the projects that I use in production with an Alpine image. And you might think, well, no shit, there's nothing there. You are basically using an HTTP client and the AWS library and nothing else. But that is kind of the point. Unless you're doing something that's very C intensive, even if you are in some cases, but unless you're doing that something, some heavy data analytics or other very specialized kind of work, I think that for regular web development or just a generic Python usage, Alpine is at a point where you can reliably use it, and it is much lighter. So it has some caveats, and you should take them into account. But I feel that people are overly negative from feelings carried from many years ago, and we've gone to a point where I think it's pretty useful for normal use cases. All right, and to finish, this is the kind of last thing I want to cover, because this is another thing that I think doesn't get just commented enough. It's kind of assumed that some people do it, some people don't. Updating the base image, should you do it? Well, the answer is yes, but the reasoning behind it is like there's an argument against it. Thinking emoji here has a lot of very good points. These are all very legitimate. So what I'm referring to, in case you don't visualize it, is just calling your package manager, saying apt update and apt upgrade, and upgrading the packages in your container file definition. There are, as you see, legitimate reasons against it. It makes your build times longer. It might bust the cache. Very briefly about the Docker caching, in case you don't know, the instructions that come below a certain point just get thrown out if one of the ones above change. That's a simplistic explanation, but one that suffices for this use case. You lose build idempotency. This, what do I mean by this? Like fancy word. Essentially, you cannot guarantee when you do this that you will get the same container file and the same code, and you will get the same container as an output. So you don't have something that will be reliably rebuildable every single time. If you don't do anything that modifies the base operating system and you don't modify the code in your Docker file, the output that you will get, you can more or less count on it being the same. So you will get the same container build. If you do update the package, you are kind of breaking that because you're changing the underlying operating system. How troublesome this is in real life scenarios, I don't think it's very much, but it is something to take into account. And lastly, you can argue, and this is a good argument also, that the responsibility for providing secure images should lie upon the people who provide those images and not be kind of delegated down to you to keep it updated. It's a good point, but unfortunately that's not the way it is, and you cannot continuously be pushing images for every single package update that the image bundles. It would be very impractical. So the counter argument is it's very plain, and you see it right there. I took this screenshot just the other day, the 3.13 Python image, just grabbed it, no cherry picking here. I just grabbed the latest image and snipped it. As you can see, it has 3 high vulnerabilities, 3 medium vulnerabilities, and 144 low vulnerabilities. Now, it is true that some of those might not be fixed already. It is true that some of these might be, let's say, pre-known to the release of the image. Not all of them will have fixes, and it's not a guarantee that all of them will be fixed at this point even. However, I can almost guarantee that a chunk of those will be solved if you update your packages, and you will have a much lower surface area for errors when you run those operations. So just based on the fact that it's a much more secure practice, even if you are losing all the things that I mentioned above, I think it's very worth it to run this, and it should also maybe be something that shouldn't even be relied upon for you to do it, and maybe done some sort of automatic way, but that's digressing. For now, you should be updating your base image. I think it's a very strong argument in view of all the weaknesses that the container can have. So that's my opinion. I think it's a solid one. And that's all I have for today. Basically, I have one last slide where, in case you didn't know about these kind of commands, you can just read them by yourself. I'm about to go over time, so I won't take you longer. So many of you will already know about this. If you don't, I guess now you know. This is one of the things that you can surely find if you just search, but you can also find a lot of kind of suboptimal stuff. So I think this is these ones are quite good and quite safe to include in more or less all the containers that you use. So yeah, that's it. That's what I have for today. Thank you.